Hi, today we are going to solve a numerical example for simple regression. Let's assume that you have the following data for y and x. Y 6, 5, 4, 8, 6 and x 2, 4, 3, 0, 3. Required estimate the parameters for this equation. So we would like to find the value of a and b. Number 2, test the significance of the parameters. Number 3, test the significance of the model. So let's start with point number 1, which is estimate the parameters. We are going to use the normal equation method, where b hat is calculated as xy bar minus x bar y bar divided by x squared bar minus x bar squared. So we have to calculate the value of xy and x squared and the mean for each one of them. xy will be calculated as the multiplication of y multiplied by x. It's 12, 20, 12, 0, and 18. And with respect to x squared, it's calculated as square of each number, 4, 16, 9, 0, 9. Now we are going to calculate the summation. Summation for y it's 29, x 12, xy 62, and finally x squared 38. And with respect to the average of each one of them, or the mean, it's calculated as summation divided by number. So it's 29 divided by, we have 5 observations, so it's 29 divided by 5. It's 5.8. 12 divided by 5, 2.4, 12.4, and finally 7.6. So now we can substitute in the equation in order to find the value of b hat. So b hat will be xy bar, which is 12.4, minus x bar 2.4 multiplied by y bar 5.8 divided by x bar squared 7.6 minus x bar 2.4 squared. So the answer will be negative 0.83. And now we are going to find the value of a hat. A hat is calculated as y bar minus b hat x bar. So it will be 5.8 minus negative 0.883 multiplied by 2.4. So the answer is 7.78. So we can write the equation as y hat equals 7.78 minus 0.83x. So this is requirement number 1. But we have to interpret the results as we study the relationship between x and y, where y is the dependent variable and x is the independent variable. The relationship between x and y is a negative relationship based on the sign. And with respect to a, if the value of x equals 0, y will be 7.78. And finally, if x increases by 1 unit, y will decrease by 0.83 units. Requirement number 2 is to test the significance of the parameters. Test of significance of parameters is performed by t-test. So we have to calculate the t-ratio, which is calculated as b hat divided by standard error of b hat. And the same with respect to a hat, it will be calculated as a hat divided by its standard error. We already have calculated b hat, but we have to calculate standard error of b hat. Standard error of b hat is calculated as square root sigma squared divided by x squared, small x squared, which means it's a deviated form. And sigma squared is calculated as summation e squared divided by n minus k, which is degrees of freedom. So n is the number of observations. We have 5 observations. And k number of estimated parameters. And we would like to estimate 2 parameters, a and b. So we have to calculate e and then square the values of e. E is calculated as y minus y hat. So we have to calculate y hat and then calculate e and then e squared. Y hat is calculated by substituting with the value of x's in this equation, which is 7.78 minus 0.83x. So we have to substitute by the value of x by 2 and get the value, 4 and get the value, and so on. So by substituting with the value of x by 2, so y hat will be 6.13. And then we are going to substitute by the value of x by 4. So y hat will be 4.478. And so on. It will be 5.304, 7.783, and finally 5.304. And then we have to calculate e as the difference between y and y hat. Y minus y hat, it will be negative 0.13, 0.522, negative 1.304, 0.217, and finally 0.696. And then we have to calculate the value of each one of them squared. So this 0.017, 0.272, 1.701, 0.047, 0.484. Then we are going to find the summation of e squared. It will be 2.5 . 2. Okay, so this means that we get this and we have this. We have to calculate small x squared. Small x squared is calculated as small x, which is calculated as x minus x bar, and then we are going to get the x squared, the value for each one of them. So as we know that x bar is 2.4, so x, which is 2 minus 2.4, it will be negative 0.4. 1.6, 0.6, and so on. And then we are going to find the value of x squared. Finally, we are going to get the summation of small x squared, or the deviated form of x squared, and it will be 9.2. Now we can substitute in the equation to find the value of sigma squared, and then to find the value of the standard error. Substitute using standard error in the t ratio in order to calculate t ratio for this variable. Okay, with respect to sigma square, it's calculated as summation e squared divided by n minus k. Number of observations is 5, and we have two estimated parameters, which is 2. Summation of e squared is 2.52. So sigma squared will be 0.84. And then we are going to substitute in the equation. Standard error of b hat is calculated as square root of sigma squared divided by small x squared. Sigma squared 0.84 divided by small x squared, which is 9.2. Square root, it will be 0.3023. We are going to do the same with respect to standard error of A. It's calculated as square root of x squared sigma squared divided by n small x squared, or we can write it as square root of x squared divided by n small x squared multiplied by sigma. So it will be square root of x squared, it's 38, multiplied by sigma squared 0.84 divided by n, which is 5, multiplied by small x squared, which is 9.2. So standard error of a hat is 0.833. Now we would like to find the value of t. T for b hat and t for a hat. As you would like to test the hypothesis that h node b hat equals 0, b equals 0, which means it's insignificant, or the alternative that b not equals 0, which means that b has a significant impact on y. And the same with respect to a, we would like to test the hypothesis that a equals 0 and a not equals 0. So t is calculated as b hat divided by standard error of b hat. So it will be negative 0.826 divided by standard error of b hat, which is 0.303 023, sorry. So it will be negative 2.7. So as the value is greater than 2, so we are going to assume that we are going to reject each node and accept the alternative. And we are going to do the same for A. It will be calculated as A hat divided by standard error of A hat. So it will be 7.78 divided by 0.8833. So it will be 9.34. So it has a significant impact, or so we are going to reject each node and accept each one. Now we are going to move to requirement number 3, which is model significance. Significance of the model is tested using two different methods, coefficient of determination or R squared and F statistic or F ratio. R squared is calculated as estimated sum squared divided by total sum squared, or 1 minus regression sum squared divided by total sum squared. Estimated sum squared is calculated as y hat minus y bar all squared, and total sum squared is calculated as small y squared, or y minus y bar all squared. And residual sum squared is calculated as e squared. So let's calculate r squared using ESS. First of all, we have to find the deviated form with respect to y and with respect to y hat. As we said that the mean is 5.8. So we have to get y, small y, which is calculated as the difference between y and y bar. So small y will be 0.2, negative 0.8, negative 1.8, 2.2, and 0.2. Small y squared 0.04, 0.64, 3.24, 4.84, and finally 0.04. Summation of y squared is 8.8. So this is TSS. Now we have to find the value of y hat, small y hat, or the deviated form for y hat, or y hat minus y bar. Y bar is 5.8 and y hat, just to remember the values of y hat equals 6.13, 4.478, 5.304, 7.783, and finally 5.304. Now we are going to calculate y hat minus y bar. It will be 0.33, negative 1.322, negative 0.4 0.496, 1.983, negative 0.496. And then we have to get the squared value for each one of them. 0.33, it will be 0.109, 1.747, 0.246, 3.931, and 0.246. Summation will be 6.278. So this is ESS. So in order to calculate R squared, it will be 6.278 divided by 8.8. It's 0.713. Or we can calculate it as R squared 1 minus RSS, which is calculated as 2.52 divided by 8.8, and it must be 0.713. So this means that the explanatory variables explain 71% of the 71.3% of the variation in Y. Now we have to calculate F. F is calculated as R squared divided by K minus 1 divided by 1 minus R squared divided by N minus K. So R squared is 0.713 divided by K, which is the number of the estimated parameter, dr2 minus 1, 1 minus 0.713 divided by N, which is 5, minus K, 2. So F statistic will be 7.47. This is the end of our example. Thank you.